So, you've seen things like table legs that are, you know, rotationally symmetric. That is not symmetric, Mr. Groom. Let's try that again. This table leg is clearly, no, it's not. It's clearly, there you go, sort of. Yeah, that's pretty close. Rotationally symmetric to that, or that line in the middle of it, yes? That is, it's perfectly symmetric. And if you chopped it thusly, or thusly, or thusly, and spun it around and looked down the business end, you'd see a circle, would you not? Can you all see that? That's pretty straightforward, is it not? Doesn't matter where you chop it, you always get a circle, yes? It's not like, weird, I was not expecting a triangle. It will always be a circle. Yes? Now here's a question for you. Mr. Groom, what if I chopped it into thinner and thinner and thinner and thinner little slices? If I chopped them really, 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 really thin, wouldn't they be, in essence, cylinders? Well, it's slanted. Yeah, but I cut it so thin that there was almost no slant to that piece across there, yes? Yes? Now, I feel like the volume of a cylinder is pi r squared times h. That's what I feel like, yes? 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 Am I right? I feel like I'm right. Now, Mr. Groom, I feel like this radius right here, I feel like that radius right there, if you follow it back, is really just some f of x, isn't it? Right? I mean, like right here, this height right here, what is that, Mr. Groom? It's an f of x, because this function across here is f of x, is it not? This is the x-axis right here, x-axis. Does that make a better picture? I'm sorry. Does that make a better picture for you? Can you see that? Nice. So wait a minute, Mr. Grimm. Are you saying the radius is f of x? I literally am saying that to you, yes. So this formula here would become pi times f of x squared times h. Sort of. Sort of I'm saying that, yeah, sort of. Now wait a minute. This is Calc 2. What have we been doing the entire term since late January? Integrals. And what is an integral really? Isn't it just adding up a bunch of little things? Isn't it? Isn't it?
Yeah.
Yes, I'm right. So, Mr. Grimm, you're telling me I could basically just add up a whole bunch of these little guys, right? A whole bunch of them. How many, Mr. Grimm? A lot of them. Like almost infinitely many of them? Yes. And so if a person were to do something like this, well, let's do I goes from 1 to n. And these are the i's in there, if you will, yes? The i's, right? So here's my question, friend. If I let n go to infinity, this thing here becomes an integral. From a to b. And most of us, Bryce, most of us big kids, write it thusly because pi is constant. Yes, girl? Oops. There should be a big fat parentheses right there. F of xi square dx. Now, Mr. Grimm, do we use the xi anymore once we've done an integral? No, we don't. So this is how we write it. And what this is called, these are what are called the this is what's called the disk method. The disk method. I just cut it into a bunch of little disks. That's all. That's all I'm doing. Mr. Grimm, this won't be very hard. No, it won't be. Should we try one? I think we should try one. What's the matter? We good? F of x squared.
What happens to f of h?
Oh, that's a great question. That is a fantabulous question. Here's the question. You might not have heard it because she whispers kind of small. What happened to our h's, Mr. Groom? Well, I feel like our h is going to be this whole distance across here from A to B. Okay. That's where the third dimension comes from. By the way, the guy who started Coast to Coast AM, if you ever heard that show in the middle of the night, it's kind of creepy sometimes. Whoa. They talk to people that have ghosts and this and that and whatnot. They always talk about aliens and crap. He died the other day. The guy did. They started the show. I don't think he really died. I think the aliens came and took him home. I do. I think he did. But he was an oddball character. Anyway, they were playing all these clips of his greatest hits from back in the day. And one of them was he was talking to the Antichrist. He had an Antichrist hotline. And this Antichrist guy called him, and it was pretty funny. And then this other time he was talking to this guy, he's like, I can't talk very long. Because it's like, if you ever seen the X-Files, they're like, the government's out to get me, kind of thing. It's one of those kind of deals all the time. And back before it was probably I don't know, whatever. But anyway, so he was talking to this guy, and he's like, they're coming for me. And all of a sudden, the radio station went dead for like 3 minutes. What? And then we're back up. That was weird. Our whole show went down. Well, they just shut it down for ratings. It's hilarious. The guy was kind of creepy. Anyway, the show is still on. He's been off of it for years. He retired, I think, in 2002. But it's kind of a creepy deal to listen to. Every now and again, I just do it just for a good time. Yeah. Now, Mr. Grimm, here is a perfectly good function, yes? This one here is sine of x plus 2. Because I feel like it, that's why. Now let's suppose we were to wrap this feller around the x-axis. That is, let's make it symmetric to the x-axis, like so, yes? And so, Bryce, I would have a bunch of little discs, you with me, that look kind of like that in the middle, yeah? Something like that, give or take. And Bryce, I'm interested in going from A equals 0 to over here to, I don't know, B equals 2 pi or some such, yes? Because that's what I do. That's what I do. Okay? So I'd like to know how much volume is there in this issue. Okay. Good, you with me on this? So, Mr. Grimm, isn't the formula just pi times the integral from 0 to 2 pi of sine of x plus 2 squared dx? Literally, that's all it is. That's right. Literally. Literally. How are you going to integrate that, though? By the way, this is totally easy to set up. Yes? Integrating this can be a bear sometimes. Ideas of how to start integrating this. Distribute. Ah, good job. Good job. That's what I would do too. You are amazing, sir. Totally well done. Attaboy. Totes. Totes. My goats. All right. So let's do the parts that we can do, because we know how to do part of this, yes? So we can do them in pieces, of course. This one I don't know how to do yet. That's a lie. I know how to do it, but I don't want to tell you yet. This piece I can totes do. Any idiot can do this piece. And of course, by the way, do I mean any idiot? I literally do mean any idiot. That's not hard. And then this piece here, really anybody can do, because it's just 4, for God's sakes. Right? All right. So what is the antiderivative of 4, Cora? What's the antiderivative of 4? 4x. Don't look at me like I'm weird. Yes, of course it's 4x. That's right. And I was put the pi right there with it. Yes? Right? From 0 to 2 pi. Well, that's hot. What do you get? I feel like this is going to be 8 times pi squared. Yes? 8 times pi squared? I feel like I'm right. Yes? Yes? Nice. All right, Shelbs. Where, sister, did sine come from? From whence did that derivative come? Ugh! Not a kid. So it's going to come from negative 4 pi cosine x, yes? From 0 to 2 pi. Do tell, Shelbs, what is the cosine of 2 pi?
I don't know.
Yes, you do. Where's 2 pi on our circle, kid? Right here, yes? What's the cosine? How far over did you come to get over there? Got it, kid. Nice! No, I knew you were. I knew you were. And what's the cosine of 0, friend? Isn't it the same thing, Mr. Groom? Isn't it also 1? It is. So what is 1 minus 1? 0. Nice. So this whole middle term, you see, cancels out. It's 0. Isn't that swell? So down here I have 8 pi squared plus whatever's going to come from this garbage here. Yeah? You with me? Let's do that. All right. How do you integrate sine squared? I'm going to do it on this page here. Sine squared x. I can't do this one, but wait. Didn't we do one like this last week? I think we did. So I think the cosine of 2x is equal to 1 minus 2 sine squared x. Yes? So I feel like divide by 2? Is that true? And then that's it, right? That's what I want. So this is equal to, I'm going to pull the half out, it's equal to this feller. See? I almost square rooted, then I'd have been screwed, huh? I didn't want to square root, I want to solve for sine squared, didn't I? And I did. Good? Let's do this thing. From who is 1 the derivative of, for crying out loud? X. And from whence did this fella come? Who is negative cosine of 2x the derivative of? Negative sine, that's part of it. That's true. Did you miss anything there? It's a half. Why is it a half? Because you have to account for u equals 2x. Is that true? So then du is equal to 2 dx. So I have a half of a du, don't I? Yes? Okay, so what I end up having here is this minus, this should be a quarter now, yes?
What about the pi?
I'm not done yet. This is just the inside piece, but good job. Good job! Nope. Oh, maybe if you go back to the right page, you nimbulb. So the pi is out front, yes? And so I had, what do I have? A half x minus a quarter sine of 2x. Is that what you have? From 0 to 2 pi. Oh, this is hot. Now, let's throw in the 2 pi, shall we? So it's going to be pi. So there's a half times 2 pi. I'm going to do this next part in my head. Is that okay with you? So what is 2 pi times 2? 4 pi. What is the sine of 4 pi? Before you ask, draw the picture. Well, 4 pi is right here, yes? How high up are you right there? 0. So minus 0, of course. And then it's going to be minus, let's plug in our zeros, shall we? What's a half times 0? 0. Good. And what's the sine of 0? 0. And so this is what I'll end up with. So this goes away. This times this times this is going to be, those guys cancel. It's going to be pi squared. So pi squared plus 8 pi squared is 9 pi squared. That is my volume. This will be measured in units cubed. Yeah. Mr. Grimm's question for Seppa. Seppa, dear, I feel like something, well, I feel like that's basically sine right there, yes? Right about there-ish, yes, of x plus 2, right? You with me? Now, dear, I feel like on that first part, we took that 4, right? Right, we had like 4 or whatever, and we said, well, whatever. But listen here. This right here, how high is it to get back up to that middle line? Well, it was the sine of x plus 2. This length right here is 2 units high, yes? You with me on this? So if I treated this as one long cylinder, we'd have that from there to there, wouldn't we? Right? Yes? So in essence, what we're seeing on this problem is, you're like, okay, well, so Mr. Grimm, what you're saying is, this part right here basically comes from this piece right here we just did, yes? So up here, when we broke this into parts, this second part right here, that part right there, is describing this cylinder across here like that. You with me on this? So we're going to see some of these as we go along. We're going to break these into pieces. And you're going to be like, oh, that's where that part came from? Exactly. Oh, where did this part come from? Oh, it came from some of this business here. That's where these things are going to come into play at. Okay? I won't draw them all like this every time, but be aware is that you could always do that. You could chop it off. Look, I've got a cylinder for part of it, and then I've added on to a cylinder for part of it, and this is where it's coming from, or maybe I subtracted off part of it. Whatever. But suffice it to say, this guy here right here is our answer. Let's do another one. We're probably going to do like 3 today because I feel like it. This is 1/2 x squared plus 2. Sure. And today, all we're doing today is we're wrapping, we say, around the x-axis. So it's going to look something like this. Can you see the discs in there, yes? Can you see what they'd all look like? Mr. Grimm, on this end is going to be a giant trumpet of a thing. That's right. That's right. Good job. Can you see it? Is that good? Mr. Grimm, we're going to go from 0 to 3. Sure, why not? Okay, I'll do that. So how much volume is there? Well, it's going to be the integral of pi times the integral of 0 to 3 of my function, which is 1/2 x squared plus pho squared. Yeah, pi r squared is what you're seeing, yes? No, maybe? Is that right? Did I do it wrong? Did I do something wrong? Is it plus 2? Yes. Oh, is it plus 2? What now, lady? Oh, I'm kind of dumb, sorry. I'm a horrible person. No, I really am. I'm terrible. All right. Now, again, what should we do here? Well, probs, we should FOIL it out. Probably every time. Would there be a could there be a situation where you have a weird... Could there be a situation where you don't? Maybe. Okay? For instance, I'll show you one here in a minute because that's what I do. 1/4 x to the 4th, is that right? Plus 2 times 1/2 is 1 times 2 of them, so it's 2x squared. And then, of course, plus 4 dx. So that's pi, good grief, 1/20, what are you doing? 1/20th x to the 5th plus 2/3 x cubed plus 4x 0 to 3. You gotta love going from 0 to stuff, friends, because on a polynomial, the bottom end will always just be 0. That's hot. So it's going to be pi 1/20th. 3 to the 5th power is 243 plus 2/3 times 27 plus 12. This is 18 plus 12 is 30. 20 goes into there. 12. 3/20ths. 12.15. You should probably check me, but I'm feeling pretty confident today. So my answer is 42.15 pi, which is 120, 130-ish. Check my math on that. Am I right? Am I right?
So what, 42.15?
Which is 130-ish?
Yeah, it's 132.42.
Nice. 132.42. That's pretty good. Mr. Grimm, units cubed, of course. Because it's falling. Nice. Nice. Yes? Seppa? Does she agree with me? She does. This is exciting. This is like a first. Seppa never agrees with me. She thinks I'm a jerk. That's fine. I don't care. I just work here. Wait, Mr. Grimm. Wait, stop. No. Wait, what if you did this, fella? Huh? Oh. Oh. Hmm. Oh, that's nice. Yeah, I like that. Sure. Nice. So here's my question. From 0 to where they intersect right there, how much volume would there be? Again, if I reflect it around the, or wrap it around the x-axis. Let me draw the picture. So my formulas, you're like, wait, don't I already know that one kind of? Mm-hmm. Kind of. Kind of, not exactly, but kind of. Somewhere over here they intersect one another, yes? I don't really care yet right now. But when you wrap this around, won't it look kind of like this, Mr. Trim? Feel like you're right. Or whatever, yes? And so it's going to be a situation like this, correct? More or less? So what if I were to chop it here? What if I were to cut it right there, spin it around and look down the business end of it, what would I see? What would it look like? A washer. What? Where there's an outer radius, and an inner radius. Wait a minute. How would you find the volume of this whole thing? How would you do it? Well, sort of. In the case of a washer, it'd be pi function squared, like before, yes, where this is the outer radius. A to B minus pi A to B of the inner radius. I'll call it G, I guess. Squared, where this is the inner radius. Piece of cake. Okay, piece of cake. What's that? Right there. Nice. It's not very difficult. It's not. Am I right? It's not hard? No, are you going to finish it? Of course I'm going to do it, Mr. Grimm. Mr. Grimm's a nice fellow. I like that. Tomorrow in class, probably what's going to happen is you're going to come in. I'm going to hand you a piece of paper. You're going to start, assignment. And you're going to start working on these in class tomorrow while I'm sitting here watching. Okay? There will be a couple of practice tonight at home. You got it right here? Yeah, good? All right. Yes, what's your question, sir?
Whatever happened to that one project we were supposed to do in this class? Alright, I said like
Which project?
Oh, like you were talking about farming and stuff? Like, you had that big water?
No, I was an example.
I know, but I mean, wasn't that something?
No.
No.
No. That was just it was a place where I had used it in my career at some point, and I said, whatevs.
What was the project?
There wasn't a project fab. There is a project for this unit. Can you guess what it would be, by the way?
Washer.
No. Go ahead. What?
Is it where we find a table leg?
Or similar.
Or
similar.
Similar. And then we calculate the volume of it.
Yes, ma'am.
We take it into class, and then you weigh it and see if it's correct.
9. So 1.9. So notice, look, x goes from 0 to 9.521. You see this? X goes from 0 to 9.521. So what were you saying, dear? So yes, you're going to get, what's going to happen is you're going to find a table leg or some such. You do some measurements. You're going to fit a curve to it. From that curve, you're going to do what we're doing here, basically. Then you have to prove to me that you're right. So how would I do that? Well, you could probably convince me if you weighed it, found the mass. You could probably find a bunch of different ways to find, because you know what volume is, if you know what the density of wood is, you can probably figure that out.
Wait, what do you mean something like it?
Like a table leg?
Something
Like
cylindrical or?
Cylindrical, but it's something that...
Like a cat stand?
No, that hand is not rotationally symmetric. This pot is rotationally symmetrical, yes? This is rotationally symmetrical, but you cannot use it.
Oh, wow.
That's lame. It's a freaking cylinder, except for this little blurb at the top. So it's a cylinder, a little blurb, and then another cylinder. That's stupid and lame. You're not doing it. So, let's try this. Now, your cat's tail? That's weird. That's just weird, bro. All right, now watch. Come over here. Stream, didn't we already figure this one out, kind of? Yeah, we did. So let's do this. But we had different numbers, yes? So let's cut to the chase, shall we? What was the antiderivative of this piece here a minute ago? We wrote it down before. It was like a half. Was it like a half? Was it a half x minus a quarter sine 2x? Is that what we had a minute ago?
Yeah.
We already did that, so let's not reinvent the wheel on that guy. Right? We had that down before.
What's the rest of it?
We're not done yet. We're not done yet. I'm just doing this part right here, bro.
No, but isn't there the minus pi or 4 pi cosine x?
Oh, yeah. So minus 4, what is it now? Minus 4 pi
Cosine x and then 4 pi x.
cosine x, right? Is that what you said?
Yeah, and then minus. Or
Okay, hang on, we're done. Let's stop it there. Stop it there.
Not the 4 pi.
But this part here I have, don't I?
Well, do you need the 4x too? Because if you distribute that, when you get sine squared x plus 4 sine x plus 4, there you need the 4x too. My favorite.
Oh, let's just start over. I can't do everything. Let's just go look
I
at
think
it.
that was the second part of the problem.
No, you're all right. Here, let's go look at it. Over here, we did it. Just to make sure we get it right. So look right here. Sam, it's right here. Sam, right here. So this is the antiderivative of it,
Isn't that just
Okay.
a sine squared though?
of that part right there. Yeah, of the sine squared. We're not done with the rest of it. That's right. It's the sine squared part. Okay, you're freaking me out, Smalls. I got you. So this part right here, that was of the sine squared part. You're right, Sam. Good job. So you're right. You're right. I was completely messed up. You're right. So there's this part right here,
Plus quarter.
a quarter. And then what was the rest of it?
Minus 4.
And then back over here, if you come back over here, you'll recall there was this part right here in the middle, which was minus 4 pi cosine, right?
Yes.
Minus 4 pi cosine. Thank you. And then what?
4 pi x.
Plus, well, you don't, oh yeah, plus 4 pi x. That's right. All right. Did I times by pi yet? Oh, those ones already got times by pi, didn't they?
Yeah.
These two already got times by pi. So let's just put the pi right here and the pi right here. Is that cool with you? Okay. So from 0 to 9.521 minus, now this piece right here is going to be 0.04x squared if you distribute it out, yes? I'm right. Don't check me. I'm right. So when you antiderivatate, it's going to be pi times 0.04 over 3x cubed, yes? From 0 to 9.521. Okay? Notice that this number here is going to be larger than this one. If it's not, you screwed up. Because clearly there is volume there, yes? And the outer volume has to be bigger than the inner volume. Yes? Excellent. What?
Why'd you start writing 0.521?
Nope. You just lazied out on me somewhere. It's okay. You're a nice feller, I guess. It's whatever. All right. So I'm going to do is because I am lazy. I am going to type this bit into Excel over here, and I think what I'm going to do is go pi divided by 2a minus pi divided by 4 sine of 2a, and then minus 4 pi cosine of a, and then plus,
Wait.
where, what?
Cosine for the x of a.
Oh, for God's sakes,
Just at the back.
Okay, where did I leave off? Right there. And then I want to do plus 4 pi a minus 0.04 over 3 times pi times a to the third power. Yes? Beautiful. And so my A's need to be 9.521. So 110.8, jot that down. 110.8. And negative 12.5. Yes? So negative 12.5, that was for 0. Okay, so we're going to minus that, yes? And then for 9.521, it was 110.8. So 110.8 plus 12.5 would be 123.3 or something. Is that what you got? 123.3 units cubed. Okay? In theory, that's correct. You know, if I'm you in the 21st century here, I'm using Desmos to crunch that number for me. I'm just doing it. I don't care. You know, TI-89, you can type it in. Yeah, you can type it in. It's a giant pain in the butt, but you certainly can type it in like that. If I had 89, it's not too bad. If I had 84, it blows because you pretty much have to just type it in with the numbers and then start over again. That's stupid in my opinion, okay? The thing about Desmos is I can change that A value to any value I like. I can do basically the same thing in my 89, and it's not too bad, but I don't want to go type all that in 80 times because all I'm going to do is screw it up. It's just dumb. Okay? So this is what I'd like you to do for tomorrow. And I'm going to change up my normal procedures for homework as well. Okay? These will be due tomorrow. Okay? Due tomorrow. Yeah, due tomorrow. Sure. Due tomorrow. Here they are. For all of these, we are wrapping around the x-axis. And so this one here, we're going to say y equals 3x plus 4. We're going to do it on the interval from 0. No, not from 0. That's boring. From 1, I'm sorry, to 6. We're going to do this one here where y equals, hey, on the interval from 0 to 4. This guy here. You'll need to do what we basically did on the sine one on this one as well, remember? Remember on this one, remember that cosine of 2x is equal to 2 cosine squared x minus 1. You'll need that recipe. I promise you, you'll need it. So jot that down, okay? Remember we did the one a minute ago, we did 1 minus 2 sine squared. You're going to need this guy for this problem at some point. You'll need that. Here, you're going to have two functions on this one. You're going to have y equals sine of x. No, that's boring. I don't want to do sine. It's boring. It's terrible, Jay. You're an idiot. Oh, thank you. Good idea. Secant x. Nice. From -1 to 1. Yeah, you'll like that one. That'll turn out nice. That one will probably stump you. But not for the same reason it should stump you. Some of you will think that, oh, I need to do some substitution. You do not need to do some substitution when you get done foiling it out. It'll be very obvious if you just slow down and just look at it, okay? And then this one here, I want to find the volume between y equals, oh, let's do a nice easy one.
9 plus 1.
2x plus, let's put a little plus on the end of it, okay? Y equals 2x plus 5. And, I don't know, let me look at that. I can't see one. Let's make one up on the graph over here. It's easier that way. So I'll use 2x plus 5.
2x plus 3.
No, that's boring. And x squared. Yes, and x squared. And x squared. And x squared. So I want the volume between them. between them in quadrant 1. And again, I want them all wrapped around the x-axis today. Now, Mr. Groom, tomorrow, are we going to wrap around the y-axis? Probably, yeah. Mr. Groom, are there other cute tricks that you're going to teach us tomorrow? Probably, yeah, because that's just what I do. Notice that there is no bound on here. You're going to need to graph them. Right? And again, make sure that you stay in the first quadrant only. Mr. Groom, could I do the whole area between them? In other words, could I go from negative whatever here, negative 1.49, blah, 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 over to wherever they cross the other side? But I just asked for the first quadrant. Okay? So make sure you get that correct. All right? Nice. Nice. Piece of cake, yes? So we're going to shake it up. We're going to shake it up. Now this, Mr. Groom, like, it literally happened on Thursday. Last night when I was doing all my homework, I never want to hear that again. The day of the test. Last night when I was doing all my homework. Okay? Okay? Because, I bet your test is going to suck. Oh, it did! Oh, it did! Not you. I'm not saying you. Yours wasn't necessarily pretty, but it wasn't you that I'm referring to. The person literally said those words to me, and I went, but their test is not going to be good. And it wasn't good. That's what happens when you put things off till the last minute. Now, I like my old style. God help me, I do. I like it because a person who's properly motivated knows that I need to budget my time, and life goes on, and that's great. Well, not anymore. Because apparently we're flipping back to the old days. This class anyways, because, I don't know, for whatever reason. I don't know. Okay? Questions on this? You jot it down? Sweet. All right. So we'll pick it up from there tomorrow. You should probably start working on it right now. Okay? I want to help.